Hello, hello, testing. Looks good. We are back. Yes. What is up? Make sure. Cool, yes. So we're back again, another Saturday. The hacking continues, the building continues. I'm excited. This is the second live hack we're going to be doing. I did one 2 weeks ago on a Saturday as well. And just a reminder, if you don't know, I guess the content schedule I'm doing now, I'm doing a live hack every Saturday, and not a live hack, I'm doing a stream every Saturday. 1 week will be the live hack. It'll be, this instance is going to be 2 hours long. We're going to be starting something from scratch. It might not work out. I'm not as prepared for it. And then on the other weeks, we have workshops. And workshops are I've prepared for it. It's structured. Things are definitely going to work out. And so doing these live hacks is just a way for me to kind of push forward right at the edge of my limit, do research for the second course, build prototypes for the second course, and kind of just get to share that raw experience, me kind of trying something new from scratch, or mostly from scratch, where the workshop is more of just okay, I'm going to condense it down and we can go through it pretty quickly and get to a end result. And so, yes, this live hack this week, we're going to try and build a simple Lightning Wallet backend using RPC calls with LND. And so what does that mean? Let me pull up my regular screen here. What is up? And I've got the chat in here now, so just trying to make this stream a little bit better each week. But what I have pulled up here, this is an app called Polar. This is something you're going to want to get if you're going to be following along. You're also going to want to get Docker Desktop set up if you want to follow along. It's this app right here, and it is pretty standard, easy to install. And yeah, you can just go to their documentation. It works on Windows, Linux, Mac, but it might take a little bit of time. But we'll be going slow through kind of the first initial setup of this, setting up our environment. And so I'm here on Polar. What is Polar? It is a really cool web app, or really a native app that goes on your desktop that allows you to simulate a Lightning network inside of Docker containers. It spins it all up for you. It does all the configurations for you, and it gives you a really nice UI to interact with. And so what we're going to be doing, when I was thinking about this live hack and thinking about just generally what do I want to show people for the second course, obviously we're going to be getting in a backend for the second course, but I wanted to show a little bit of some lower level backend stuff and more of a fast and dirty full stack app. So 2 weeks ago we did kind of the fast and dirty full stack app with Next.js and MongoDB, and we use Voltage and LNbits. And so I'm going to refine that, and that'll probably end up as one of the projects in the course. And I would like this also to end up as a project in the course, where here what we're going to be doing is making a Node.js app that connects to an LND node through a gRPC library. And then when we're connected to our node, we can kind of call and talk to it, send data, receive data. And once we do that, we can only really do that in the Node.js environment, because Node.js, it's just like JavaScript on your machine, where regular JavaScript, it's JavaScript, it's in the browser environment. You don't have access to your local resources on your machine or anything like that. But with Node.js, you do. That's what we need in order to talk to our node. But then from there, we can put those methods where we're talking to our node, we can put them behind API endpoints. Just really simple API endpoints that we're going to build with Express, hopefully simple. And then once we have those API endpoints, our pleb wallet, the pleb wallet that we built in the first course, could talk to this server, talk to this API and call the node directly instead of using LNbits. So that was the simple idea here, because the pleb wallet is already, it's kind of like the most simple implementation of a Lightning wallet, because all that you can do with it is create invoices, pay invoices, and you can see your past transactions. And so that shouldn't be too difficult to build. But I think we should probably just get into it. Any other prereqs we need? I'm trying to think. Yeah, mainly just Docker Desktop and then Polar. You get those up and you should be good to follow along. This is assuming you have Node installed on your local machine, or NPM if you ever run NPM install or anything like that. That will work. Let's get into it. So I'm gonna start. So we might get to some database stuff as well. I'm not totally sure. Just like a simple SQLite database, but I want to make sure first of all that we're talking to our node and we're getting the data we need, and that the API endpoints that are calling those methods are working. So all of this might stay local. We might not have the database spun up during the session, but at least I'm going to try and put comments like in our code where we would say like, okay, this transaction's complete. Let's save this transaction to the database and stuff like that. But we'll see how far we get. So let's get started here. So where do we start? I guess I'll show you first of all the library that we're going to be using to talk to our Lightning node. It's this LND gRPC. Let me pull up. Here's the actual GitHub. So this was made by the Zap team. It was made quite a while ago, but they've been updating it somewhat. And I looked at a few other libraries for talking to Lightning nodes. And there's a few other good ones out there. There's LN-Service, which was made by Alex Bosworth. I know a lot of people use that. But I really liked this one. I liked the simplicity of it and the docs and kind of how it shows you how to connect. And so this is just, it's just a library. We just npm install it. We can import it in, and then we can spawn up a connection to our Lightning interface. And so showing you here, like, yeah, gRPC equals this with options, but there's quite a few options in here. A decent amount of them are optional, but we can get this information from Polar in a second. But, we'll create a connection. So here, I guess they're showing you a little more verbose example. And yeah, you connect, and then you can just like see if you're connected basically. So that would be the first place for us to start. And I guess before we get into that as well, let's talk about RPC a little bit. So if I pull up, I've got the LND docs right here, and they have this full API reference. It's really good. But what is an RPC command? What is this thing we're doing to talk to our node? So this is something that it's at the cutting edge of my knowledge, definitely. I'm just now starting to work with the RPC interface for the first time. But the simple, I guess, summary of how I think of it is that we know about APIs, so API endpoints, GET request, POST request. The API is kind of like, it's a messaging interface for machines on a network. So, you've got servers on the internet, and how are those servers talking to each other, or how are they talking to the clients? They're using the API. And it's just, application, what does it stand for? Protocol interface. It's just an interface for sending messages. So this is all that RPC is. But RPC is kind of like more of the lower level in your machine interface for talking between different resources, different libraries, different packages. So I think you can talk machine to machine with RPC, but usually when you're dealing with RPC calls, you're getting really a lot lower in the stack to where you're calling at like the deepest level of the libraries or your machine. And I think some of the other differences is like the RPC calls, they're a lot smaller, they're a lot more condensed, but there's a lot more that goes into it. And so I'm just going to show you an example. Let's do add invoice under the Lightning service here. And so here in the docs, it's nice, they kind of show us, they give us a JavaScript example of what it would look like if we were doing this just completely raw. And so we're importing these libraries. We have some of these options that we saw in the library before. But just generally, there's a lot of data here. We have to deal with the proto loader here. We basically have to encode data. If we're talking to the RPC at the lowest level, we have to encode and decode the data. And there's a lot more of these intermediate steps that go into just kind of reading and setting up the connection. And so I didn't want to do that. I was like, okay, let's find a more simple way to do this. And so that's what the LND gRPC library really is. It's an abstraction above the raw RPC calls. Just a little bit of an abstraction that makes it easier and kind of takes care of that encoding and decoding stuff for us. So we can just call this library directly, just like we're calling a regular method. And yeah, I mean, it should work, and we don't need all of this boilerplate for the most part. And so that's the reason for using the library. That's kind of what RPC is. RPC is how we're going to talk to our node. Okay, this seems like a good starting bit of knowledge to go running with. So let's just I'm going to create a brand new folder, and we're just going to start from an totally empty folder. So I'm going to call this pleb wallet-be for backend. And boom, I'm just going to drag it into my Visual Studio. And we're going to start, I think for the first time, just start in a completely empty code base here, completely empty repo. And so what are we going to do first? So this is going to be some basic Node.js stuff. So we've done like create React app before, where it kind of spawns up the basic project that you then refactor. But this time we're starting from zero. So the very first thing that we're going to do is we need to kind of initialize this as a node project. And so the easiest way to do that is running this command, npm init. This will initialize npm, and it will create a package.json for us. Yeah, and then we can start installing libraries from there. So we're going to do npm init, but we're going to throw this flag on here, -y. And -y just stands for yes, and it just means I accept the default configurations, meaning I don't want to like configure every little thing inside of here. So we'll do this, and boom, there's a package.json. And so this is just the default configuration it gives us. There's almost nothing in here: a name, a version, a main file. It defaults to index.js. Yeah, and then scripts here, we'll mess with this soon. And from here, we can now start installing libraries, as crazy as that is. So I can say npm install LND gRPC. This will be the library we're using. And now this will create a package lock.json that will lock in the versions. We never need to look at that though. And then our node modules, which is the actual packages in here. And so I guess just like a little bit of a review on dependencies, like I just installed one package, right, into my project, but now my node module is filled with all of these like 20, 30 different packages. Well, this is why dependencies are called dependencies. This is why we don't just call them packages or libraries all the time. Like the one LND gRPC library we're using depends on all of these other packages. So to get the one, we have to bring all of this along. And so this is why kind of the really good devs that are working at the lowest level, they're always trying to reduce dependencies. They're always trying to reduce the bloat that can happen inside of your project. But we're pleb devs, so we're not going to worry about that. We're just going to get all the packages we want and go running. But either way, this isn't a bad start. Just a note on that. So cool, package.json is here. I'm going to go ahead and initialize this as a Git repository as well. I can do that with git init. And so we don't see the file here because it's a hidden file, but there's now a .git folder actually inside of this directory. And we see instantly these light up, and it's telling me here on my source control that I have 1,233 pending changes. Ooh, I need to try this out. I actually wait, that's not how you do it. I got this zoom in thing now. Yeah, okay. Anyway, so we've got all these changes. So we don't want to add all these changes, okay? We don't need to push up our node modules. So how do we do that? We're gonna add a get_ignore dot get_ignore. Call it that, it'll instantly recognize it, and we can put in here just one command, node modules, and we're gonna tell Git we want you to ignore node modules. Okay, cool. So now we only have 3 changes, which is our .getIgnore, our package lock, and our package.json. So good simple start here. So now let's make our index.js file. And what do we want to do here? What do we want to do first? Do we want to, let's just, let's see if we can connect to our node first and foremost. So I'm going to start to set up some boilerplate for this. So I did a little bit of research before going into this just to get like the minimal amount of exposure to know that I wouldn't get stuck like 15 minutes in. And you can find that, let's see, in my repositories. I just wrote a bunch of like quick and crappy code. It's right here, LND RPC test. And everything is in index.js. So I kind of have this pulled on the side, and I'm going to use this as a reference so we can move a little bit quicker. And then, of course, I have GitHub Copilot in here as always, which is going to autocomplete some of my code here. But yes, so first we're going to set up our connection. And so our connection is going to deal with these secrets we have. So let's look at the library again here. And it kind of tells us we're going to have a host. Well, really, there's a lot of these properties here. I had read through this already. So there's something called LND Connect, which is another way through WebAssembly, if you've heard of that. It's a way of connecting to your node. We're not going to be using this, but it is a pretty quick and easy way. It kind of compiles all of this connection information into one call, but we're not going to be using that. This is optional. What's required is a host, a cert, and a macaroon. And then wait for cert, this is optional, this is optional. Version, if you know which version you're connecting to. By default, we use the latest proto files available, so it should default to the latest version, that's fine. Okay, cool. So let's take this object right here. I'm just gonna copy it and I'm gonna put it in here, and I'm gonna say const options equals this stuff. Okay, save that. And so these options are wrong, so I want to get the real options. But let's put in the rest of this code so we can connect. So yeah, we'll just do this. We can say state, print that out. Okay, so we would pass in options here. Oh, and I'm missing something very, very important. My import, I need to import this library in. And so if this is your first time kind of looking at Node.js, imports and exports is one of the concepts that's a bit different. We have what's called module exports and module imports inside of Node.js. I mean, not worth getting too much into detail. It's mainly a syntax change for us. So yeah, I'm not going to get into the details, but how you import is we're going to say const, what are we importing? LND gRPC equals require. Okay, there we go. So we use this require method and we call the name of the library, and then that's how we do our import there. And then when we're ready to export, we'll say module.exports equals gRPC. Cool. And so this won't work, but let's just make it throw an error just for fun. And I can show you how to run this. So how we run a file inside of a node project, once we have our package JSON and everything set up, I can type node index.js. I could call this test.js if I had a file called test. You can call it whatever you want, but index is our root file. So I'll run this and yeah, we'll get an error. Await is only valid in async functions. Okay, that's actually going to be a problem. So let's wrap this in async function. I'm just going to say const connect equals async. And we'll just close it right there. And then we'll need to call this function at the end if we want it to run. It says ready. Okay, well that's cool. It's not connected, but it's ready to connect, I suppose. And just a reminder about async, if you forget, it takes quite a few passes to learn about the asynchronous code stuff in JavaScript. But anytime that we are calling something that it won't come to us instantly. Like here, we're trying to connect to another machine. We don't know how long that will take as far as like in milliseconds. And so sometimes we need to await stuff. So we write it in an asynchronous function, this asynchronous block of code, and we're saying, okay, await for this to happen, and then you can move on. If we don't await it, if we just did this, then maybe we would start connecting, and then we would just start going down the line to the rest of our code and start running other code, and it would just break everything. And so it's quite funny, like a huge number of errors and like problems that people run into in JavaScript is asynchronous code, async await. But yes, this looks good. So it's ready. So now we're going to go into Polar and get our little node local environment set up. And so to open Polar for the first time, you'll need to have Docker Desktop open. So you'll need to have Docker Desktop installed, and you'll simply just open it because it'll need to kind of be active. And then when you come to Polar, you'll be presented with an empty screen. I already have a few networks I created here, but I'm going to create a new network right now. And none of these are running. They would have green lights if they're running, so they're all off. So I'm going to create a network. And so this network, we're going to call it pleb wallet BE. And I'm just going to get 3 LND nodes. And what's cool, you can get LND, you can get Core Lightning, Eclair. Very cool. You can kind of like simulate all of those different nodes. Well, not even simulate them, you're running them in a Docker container. And test your app development with that. Like really, I think Polar is really like the standard of kind of setting up a development environment to work on Lightning at a low level. At least from my perspective, it abstracts and takes away all of these concerns that can get you stuck for days. So new network, 3 LND nodes. We're gonna have a Bitcoin Core node is gonna be the backend for our Lightning nodes, and we're gonna create our network, and it'll be easier to see once it's all visual. So we get this beautiful UI here, and we can see that we have our Bitcoin Core running as a backend, and then we see that there's 3 individual Lightning LND nodes that are spawned from that one backend. And so this is going to be our little network that we're going to test with. So first of all, we need to run start here, and this will take a second. And you'll see the blue lights should turn green as it becomes like actually active. So our backend has spun up correctly, and now our Lightning nodes are starting. And okay, there we go, all green now. And we are at height 0 or height 1. And so let's talk about RegTest. Have I mentioned that this is RegTest? What is RegTest? So what we're doing here is we're making basically a little Bitcoin network with a little Lightning network on top of it that only exists locally. And so in Bitcoin, there's quite a few networks that maybe you heard of. Like there's Mainnet, obviously, that's the Bitcoin we all know and love and use that's been live since 2009. And then there's Testnet. You may have heard of Testnet. Testnet is like the test environment for Bitcoin, but it's deployed globally. So I can run a testnet node, I can connect with someone across the world with that testnet node, and we can, send each other testnet coins. So it's a global network that's a test network. RegTest is a local network that's a test network, right? So we're running Bitcoin, we're running Lightning, we have the network, we're running the same software essentially, but this is a version of it that is meant to run locally. It's meant to be easy to test with, easy to kind of manipulate. And it's exclusively for development. And so that's what Polar is. It's all reg test. So like, these nodes, you could not connect to them if you wanted to. They're only on my machine. And when you spawn your Polar environment, it'll be the same thing. So that's kind of how reg test works. And so we've got our reg test environment here. That's why we started at the 0 block, and now we're at the first block in the Bitcoin history. And so I guess the first thing we want to do is connect. So let's connect with Alice. So if we click on any of these nodes, we get these kind of sidebar tabs where there's info, there's connection options here, and then there's different actions we can do, like depositing funds, opening channels, etc. But we want to connect. And so what we need to connect is our host, our gRPC host. So this is just actually like, the IP address and the port of where you can connect to. So it should be pretty understandable. So we'll grab this piece first, throw it in here. It's our first option for the host. And then next we're gonna have our TLS cert and our admin macaroon. I'm actually not sure what the TLS cert is for. I haven't worked with it at that low level. But I do know that a macaroon, we're just going to point to the path where this exists. So just copy this path right here. The admin macaroon, there's invoice macaroon, there's read-only macaroon. Macaroons are these ideas of, well, they're cookies, but in real life, but in Lightning, it's this idea of kind of baking scoped permissions. How do I explain that better? Those are kind of fancy words. It's a way of creating an object that we can give to someone that will give them certain permissions to our node. So yeah, it's that simple. And so with the admin macaroon, we're giving them full admin access to our node. They can make invoices, pay invoices, drain our balance, anything. Invoice macaroon gives invoice permissions, and then read-only macaroon is the read-only permission. So like, you could imagine maybe you're running your own Lightning node at home, and maybe there's some service, some online service that gives you like node statistics and advanced capabilities with your node. If you're going to connect to that service, you might give them your read-only macaroon so they can read your data and give you a dashboard and give you insights and all of that. But you don't want to give them your admin macaroon. That's almost like the equivalent of giving someone a private key to your Lightning node. But here, since we're developing locally, and also this is going to be our own backend for our own node, our own wallet, we are going to use the admin macaroon. We're just going to have full permissions so we don't run into any issues. But yeah, that's kind of a basic overview of macaroons. Sweet. And so, yeah, different times when you're connecting to your node, like they might have you put in actually the hex for your cert and the hex for your macaroon. And you can grab those right here. So you can get like the raw hex value. They've got base 64. But we're just going to point to this file path, which is actually saving it inside of our Polar environment. So Polar generates all of this for us. It's all in the right place, and you just got to grab it. It's really nice. Okay, so let's run this again. We've updated our options, and let's see what we get for connection. Active. Okay, there we go. So originally when we ran this, we had this ready command, and now we have, or ready log, now we have active. So that's showing us that we should be connected now. So I guess one of the best ways to see if we're connected is to look at our wallet, see what our balance is. So now here's the part where there's some information in this LND gRPC library, but since LND gRPC, it's just a wrapper for the actual RPC calls. Really, we're going to need to go to the Lightning Labs API to look at a lot of these calls we want to make. And so I want to see our balance. So how do we do wallet balance? Let's just search on here. Wallet balance, okay. So wallet balance tells us it lives under the Lightning service. And in these JavaScript examples, I'm going to kind of use these to try and tell what do we need to pass to this function, like this method wallet balance. Like what do we need to pass to it to get our wallet balance? So I'll be coming down here and I can actually see they've got all this boilerplate up here. We're kind of going to ignore it and just wait for, here's where they're making their connection. And then they're creating an empty request object and they're calling client.walletbalance. Cool. So empty request, we don't need to pass anything in. We should be able to just call it like a method. And so in order to call it, we need to get the service. And so if we go into the gRPC, we do dot, we're going to have services here. Services. And let's just console log that. Let's console log gRPC dot services. And this is where we'll go into to access all the methods we want. So run this and we get a bunch of raw JSON here. Not super readable, but you kind of at the top level here, we see like wallet kit. This is one of the services. Signer, router, but we want the Lightning one. Here's invoices. Okay, so let's say grpc.services.lightning. And so this is something I kind of figured out earlier if you're confused. It's just once we initialize and make the connection, then we have these different services, which like are right here at the top: Lightning service, invoices service, peers service. And each of these services is what actually has the methods that we can call. So let's run this again. We'll console log. Okay, so now this is showing us all these different methods on here that exist on the Lightning service. And so we should see at the bottom, I guess it's not in alphabetical order. There should be a wallet balance here somewhere. Wallet balance right there. Boom. So I'll copy that and let's just call it. Let's say const balance. We're going to assume we need to await this equals await grpc.services.lightning.get wallet balance. That looks correct. And then we're going to console log our balance. Okay. Let's see what we get. Get wallet balance is not a function. I think it was just wallet balance. Cool. Okay, there we go. So we have our first log here active, and then we have our balance, which is coming in here, which is 0. And so now here's where we can go back into Polar. So I have Alice selected here, and I can just easily go into actions here and I can deposit funds. So I'm going to give Alice 1,000,000 reg test sats in her Lightning Node wallet. And this will take a second. And actually, a little known like Bitcoin trivia fact, are we going to be able to receive these sats on the first block? Because we're still on block height 1 here. What's going to happen if we try and deposit these sats on the first block? Let's see. I actually don't know if Polar automatically takes care of this. Okay, there we go. Deposited 1,000,000 sats to Alice. And if we look, height 107 now. So we had to go 100 blocks in the future to kind of get these funds for the first time. That's a little bit of an old quirk about like how Bitcoin works from the Genesis block up. But yeah, so Polar took care of that. That's really nice. We didn't get any gross errors. But it had to take us to block 107 before we could have these sats available to spend. And also get them in a Lightning channel as well. Because not really a Lightning channel, but spawn our Lightning node from our Bitcoin backend. So Polar took care of that for us. And we now have this 1,000,000 sats balance. So let's run this again, and we see here that we do indeed have our balance. Very cool. So that already can be one endpoint that we're going to have, because if you remember the Pleb wallet, I mean, one of the obvious things we show is your balance. So now maybe would be a good time to start to get into the API a little bit, start making our first API endpoints, and set up Express. Express is going to be the library we're going to use for building our API. So let's do that. We're going to run npm I express. And there's a few other libraries we're going to use here as well. I'm just looking over at my reference here. That's for logging, .env, cores. Yeah, let's just do that. Okay, so we're going to do npm I. We're going to say cores. And we're going to say .env. So these are two packages. We're also going to add what is cores and what is .env. So cores is, gosh, how do I even explain cores? It's the cross-origin like site protector for API calls. It's basically like a protocol for trying to identify and block like spammy API calls. And so we just want to pull in the cores package so we can initialize it inside of our server here, and then basically say like, hey, this is a server that we made. We want to send requests, receive requests, all of that. And there's not going to be much we're going to do with it. We're just going to invoke it. And then I added .env, which, if you remember, is going to be the package we use to help us store our secrets. And so unlike in a React app, like before, where we had secrets sitting inside our React app front end, we couldn't really fully hide them since the front end will always get bundled up and sent over to the client. There's nowhere you can hide something inside of there. I mean, you can kind of try and encrypt it and hide it in there and be all sneaky, but really fundamentally, it's all getting bundled up and sent to the client, so the client can find a way to parse it and pull our secrets out. In the server environment, instead, we can just easily create secrets that we're going to use inside of our project and keep them secret, keep them hidden on our server that we're going to host it on. So that is cool. So since I have that installed, I'm going to go ahead and make a .env folder where we will put our secrets. And I'm going to have a port. This port is just going to be what port we're going to run our server on. I'm going to make it 5501, I guess. And we're going to have a host, cert, and macaroon. And we'll just copy this information over so we can just start with some pretty good security here, or some basic security. So the path to our cert, and then the path to our macaroon. Cool, I'll save that. And so now, oops. Okay, and so now we've got that in, we can replace what's in these options. But first, I'm going to import, what am I importing? .env equals require .env. And at the very top here, it's going to know what I want to do already, .env.config. So we simply just call this method, and then our secret variables will be available to us on the process object, if you remember that. So what that's going to look like here, I'm going to say process.env.host. And it'll all be in caps, of course. Do the same thing here. It'll probably autocomplete for me. .macaroon. Cool. So our secrets are in here. And what else are we going to do? We're going to bring in express. Const express equals require express. Did I spell const wrong? Ooh, not a good look. Okay. So we have express in here now. And for some of this stuff, like I don't want to have both my server stuff and my like I want index to be the very simple entry point to this backend. And so we're going to kind of pull some of this code out and move it around, try and organize it a little bit. So I'm going to create an lnd.js file, and we're going to move some of this crap in there. Move in this. We don't need this export anymore because of that. So here we are. So we'll need our libraries.env, and then we'll need to do our export again. Module.exports. Okay, cool. Oh, and we need to call .env.config right here. Okay. And then we're going to create a server folder as well, or server file, server.js. And this is where we're going to initialize our Express server. So let's go ahead and do this. Import Express equals require Express. And how do you make an Express app? It's actually really simple. I can say const server equals Express, and I invoke it. And really, it's quite that simple to just initiate an Express app. But we want to use this server so we can create our first endpoint here. Just copy this over from my example. And this is just a basic endpoint that's using our server object. We're saying server.get, so we're going to listen for a GET request on /. So that just means the location of our local host. And we'll just say result or response.status 200. So we'll send a success status of 200, and we'll wrap this JSON message here. And I'm going to want to do module.export server. And what else do we need to do here? I'm going to add on these two packages. So actually, no. So we're going to add on the cores package, and then here we're just going to tell Express to use JSON. We're going to use the JSON format, so we're just configuring that. And then below, we're calling cores just to say, like, hey, please don't block our requests. You know, we have your package. I really don't fully know how cores works. I've just run into 1,000 cores errors. I feel like that's how most like devs are. I don't know. Any like cores experts, geniuses in here? I don't know. Tell me what's up. Okay, cool. So we've got our server here, but we want to start it. And so where we're going to go to start it is index.js. This is where we're actually going to start everything. So I'm going to go back to index. We don't need most of the stuff here. I'm going to say const server equals require ./server. So this is the first time we're importing another one of our files. So works very simply or very similarly to what we're used to. And I'm going to need .env in here. And then, yeah, .env config. And I'm going to say const port equals, yeah, it knows what I want to do. So we're going to say our port that we're going to run our server on is either going to be our secret variable that we use for port, which is 5501, or we'll default to 5000. And then finally, we just do a final server.listen. We're telling it to listen on the port, and it will console log when we're on the port. Need to close that. Okay, cool. We just added a lot of code. So let's look over this a little bit one more time. So our index, this is our starting point. We're pulling in the initialization of our server. We're giving it a port, and we're telling it to listen on this port. And then our servers was our server initializing. It's pulling in the packages. It's starting the Express server. And then it's giving us an endpoint here at the base/endpoint for a welcome message. LND is actually doing nothing right now. So we could actually call, let's do that. Yeah, let's have this initial welcome message actually call the connect. So So we have this connect function, which will do that. Let's add it as an export. So module.exports will be connect, and we'll export our gRPC. And so now, inside of server, we can import connect. Oops, I did a React import. Const connect equals require. So pulling in this module, and then as we're starting up our server, we can just invoke connect. How are we telling grpc.state? I see. So let's call connect in here. Just invoke it, and let's pull in gRPC, and then server listening on port, and we'll do another console log here. Yeah, and we'll just console log the state of our connection to our node. Okay. Let's see. So now we want to start up our server. Oh, I'm going to add one more package here that's going to make things just a little bit easier. I'm going to say npm I node mon, and this will give us a package that kind of just lets us, it keeps our server running as we are making changes, and we'll refresh it automatically so we don't have to keep on restarting all the crap here. Yes, so we will do this actually in the scripts. So we have scripts here. This was our like basic, package.json that we generated. We now see our packages that we added in here, our dependencies. We have this test script. I don't want it to be test. I want to make a script called start dev. And this will let me, and yep, it knows just what I want to do, nodemon index.js. So I'm just going to call the nodemon package. So I'm going to tell it, hey, I'm going to start index.js, but keep it alive and keep refreshing it as we're making changes. And then we're pointing to index.js, obviously. And so since this is a script on my package.json created with npm, I can call it with npm run. So I can say npm run start-dev, and hopefully we will see our server starting here. Okay, server.use cores. Cores is not defined. In my server.js, yeah, we just forgot to import that. Import cores. Let's try it now. Lazy router. What does that mean? Express lib application. Cannot read property of undefined, reading lazy router. Not sure what this has to do. Don't need connect. Let's see. Is this an issue with cores? Let's try this. Nope. Shouldn't be express.json. Let's go into index here. .env.config. Maybe running connect here is throwing us an issue. Cannot read grpc.state. Okay. Probably wasn't a good idea to call this right here. So let's actually move the connect and the state. Let's move this to our endpoint that we're going to call here. So const connect equals require from server. And we're going to bring in connect and gRPC. And so after we start up our server, we'll run connect and then say welcome. And then we'll say, let's see, connection status. Say grpc.state. And we need to make this a backtick so that we can put in this variable. Cool. Connect is not a function. Oh, this is supposed to come from lnd.js. Cool, there we go. Oh, and we still have our balance being console logged here. Okay, so now we have a server running. We're still doing the same connection. We're showing our wallet balance right here. So how do we test this? We're going to open up Insomnia and we're going to make an API call to our own server. How exciting. So I'm going to make a new request here. It'll be GET request. We'll do just HTTP // localhost. And what do we choose? 5501. And let's see what we get here. Boom, welcome, connection status active. Beautiful, okay. So our server's running, we got our first API endpoint working, we're connected to our LND app, or we're connected to LND for our Lightning node. So that's a great point to be. So what do we want to do now? Trying to think. We're connecting. Let's create an invoice next, I suppose. Can create an invoice, and we can actually have Bob here try and pay it. So I think that would be a good next step. So inside of LND, let's actually take one more step with our server here, and we're gonna make a Lightning router. Yeah, I think that's a good idea. So what we want to do is we want to have like the base level of our server here just be like a welcome message. And then we want to make it to where if you call /lightning/pay or something like that, that you'll get an endpoint. And so what we'll do is we'll create a new route for that with Express. So I'm going to make a new folder here. I'm going to call it Lightning. And lightningrouter.js. And here is where we'll look over my reference code, make sure I don't forget. Yes, we import it just like this, where we're calling the Express router, and we're just going to go ahead and invoke .router right here, so we can tell we can tell Express here that this is going to be a specific route. And I want to make, let's just make a simple endpoint here for, let's say, balance. So not const, I'm going to say router.get, because this is going to be a get endpoint. And it'll autocomplete some of that here. So we're going to call this balance. And where do we get our balance from? We're going to get our balance from LND. So we have this connect. Let's just make a const get balance function here. That looks right. Get balance, return balance. It's async and await, and we'll get rid of this code right here. And we'll make sure to export it, get balance. Okay, and now I can put this behind my endpoint. I can say get balance dot then dot catch. So since it's asynchronous, that's why we're using our dot then and dot catch here, I suppose. We can also do this other ways, but let's just try this and see if it works. So we're gonna have a balance endpoint here, but where's the balance getting added? It's getting added on our new router. And so this is where we'll say, yes, it knows exactly what I want to do. Server.use/lightning. And then we're pulling in our Lightning router here. Let's actually import it though, because we don't want to do a require statement here inside of our function. So I'm going to say const lightning router. Yes. And then we can just pass that in like so. Okay, module not found. ./lnd.js. Of course, it's because it needs to be dot slash, I believe. Router.use requires a middleware function. We got a server.use, server.use. Needs a function, but it got an object. Okay. Probably just forgot to export or something like that. Yes, I think I need to export the router here. Oh, okay, I think that worked. So let's try. So now we should be able to, since we defined the new endpoint Lightning, and we put our Lightning router inside of it, which has this one endpoint, but there can be multiple, we should be able to call a get to /lightning/balance. There we go. Nice. Okay. So a lot of like boilerplate and project setup here, but it's good to kind of get organized before we dive into any more complexity. So I think this is a great place to be. So let's get paying an invoice now, or creating an invoice. So get balance, so we'll make a new function. We'll call it const create invoice. And I need to find the method here that lets us create an invoice. So I think it's add invoice. Add invoice attempts to add a new invoice to the invoice database. Any duplicate invoices are rejected. Therefore, all invoices must have unique payment preimage. Okay. Let's see from our code sample here, what do we need to pass in? So here they're making their new client, and then they're creating this ginormous request object. I hope we don't need all of these fields. So client.addInvoice, request, and then they're just console logging the response. So let's see what these, it has a description of these parameters down below. So memo, we know what a memo is. We used this in the PlebDev course on the Pleb wallet. This is just an optional kind of message that we can attach. Preimage. REST placement, REST type. I know we'll need value, the value of this invoice in Satoshis. Let me pull up my reference project. I think I did this here, not Pleb Wallet React. This was LND. Let's find it again here. So is my messy old code I made earlier this week. We're using add invoice. It's commented out for some reason. Looks like we're only passing a value in a memo. So let's try that. And add invoice. What service does it exist on? We need to see how we call it. This is under the Lightning service. So it'll be very similar to this line here where we're saying const balance. So I'm just gonna paste this in. We're gonna say const invoice equals await, gRPC, services, Lightning, and it'll be add invoice. And we'll pass in, we'll have amount, we'll have memo. And we will say value equals amount, memo equals memo. Wait, is it value or amount? What are we passing in here? Value. I don't want to have two different names for things, so I'm just going to call this value. That will be the parameter this function will take in. We call an invoice. We get our invoice here. We're awaiting it, and then we return it. Seems simple enough. Make sure to export this, create invoice, okay? And now we will call this behind a new endpoint. So this will be a post because we're going to need to post data for this. So we'll do router.post, and what do we want to call it? Create invoice. I don't know. Need to pull up stream. Am I still live? Okay, I'm still live. Forget to check on it. router.post. We'll just make it, yeah, slash invoice. Invoice. We'll try and complete this for me. Just get that, okay. So our request and our response object, I now need to import this. I'm getting get balance. We'll do, what is it, create invoice. And so I think we will call it in a similar way. Let's see what this did for us. So destructure the value in the memo. We call our create invoice function with value in memo. This seems right. And then we expect an invoice. We'll pass it back with a 200 or else we'll catch an error. That looks good to me. One thing with creating API endpoints is like it's a lot of boilerplate. I really like using GitHub Copilot for stuff like this because a lot of times you have to refactor it either way and dig into the details, but it's nice to be able to, like, especially if you have like a data scheme, data model, and you kind of have everything planned up front, you can just lay out your endpoints, lay out a bunch of boilerplate basic endpoints, and then kind of fill them in specifically. That's what I like to do when I'm making big APIs, but we're kind of going to go request by request for this project, so it should be fine. So, okay, so router.invoice, let's try it. Make a new request here. This is going to be a post request, and I'll just copy this. So lightning / invoice. We're going to make a JSON body, and we'll have our memo will just be test. And what was it, value? Let's make it 420 sats. Okay, so I think we should be able to do this. Let's just run it. 200, okay. We created an invoice, amazing. We get back this giant object. I guess it's not that giant, but we're gonna have our, what is this, our R hash, payment address. And it's telling us it's type buffer. I think this means it's like a different encoding. I'm not quite sure how that works, but this is really what we need right here. This payment request field is our actual invoice. So let's copy this. And there's a cool tool I have here, invoice decoder. So you can always come here and just throw in any invoice and get details about it. So get details about this, tells me the amount in millisatoshis, tells me the chain, it knows I'm on reg test. Here's our amount in satoshis, and our description test, which is really the memo we sent in. So it looks real, the invoice looks real. Can we have Bob pay it though? We want Bob to pay this. But we need, what do we need to do to get Bob to pay this? We need to open up a channel. So for Bob to pay Alice, Alice will need an inbound channel from Bob. So I can have Bob selected here. I can go to actions. There's this open channel. I can say incoming or outgoing. We're going to go outgoing to Alice. So open new channel. The source is Bob. The destination is Alice. Oh, and we need to first, actually, I need to give Bob some funds. So we'll deposit him 1,000,000 sats. Then open up our channel to Alice for 250,000 sats. That seems good. Let's see if it works. Let's see if it works. Sometimes, yeah, Polar's not perfect, but okay. Nice, it's really good, cool. So now we can actually move these around, and we've got this UI right here that's showing us this channel visually. It's very cool. And we can see the source, destination here, so we can see it's coming from Bob, it's going to Alice. So it's a nice way to visualize our channel. So Alice has inbound, so she should be able to get paid. So let's see if Bob can pay her. We'll have Bob here, pay invoice. I'll paste this in. Let's see, sent 420 sats from Bob. There we go. That seems like it worked. So let's get the balance again. Get the balance again, but the balance is the same here. The balance is the same. Why is the dictionary popping up? So why is the balance the same? The balance is the same because this balance endpoint we're calling here is going to LND. We're calling lightning.wallet balance. And so this is where, this is where we dig into the details. I mean, just look at this API here. Like, there's a lot of configurations here, a lot of data that's being stored. It's being visualized in a lot of different ways. And so this is just where things get complicated, where you go from more an abstracted level, like before we were using LNbits. LNbits kind of took care of a lot of this stuff, gathering our data together and sending it back to us. But now that we're at the lower level, we have to deal with this ourselves. So we have a channel balance. We have a channel balance and we have a wallet balance. So I can see the channel balance RPC call here. We don't need to request anything. That's nice. So it can just be a GET request. But this is something else we need to get to see our updated balance. So let's we're saying get balance here. Let's make a new function, const get channel balance. And let's make sure channel balance. One thing that's weird is like with our LND RPC library here, the methods that we're calling, it's a little bit different. Like you can see here on the docs, everything is uppercase. They call that Pascal case, I think. I don't know. But ours is camel case, which means that the first letter is going to be lowercase, and then every word after it will have an uppercase letter that it starts with. So that's how we have to call the methods here. Like if I change this to channel balance, it would not work. So we're getting channel balance, and we're just going to return it. So easy. I need to close my function. And it's just a regular function, right? Yeah, okay. Here we go, and we will export this, get channel balance. And now let's put it once again, Pinot endpoint. So, router.get channel balance. That's a good enough name. We'll do that. And Copilot should be able to just generate this code. It's all just going to be super similar. Since this is one of the nice things about abstracting. I mean, since we're abstracting like our RPC methods into this LND file, we can make our API just as standard as possible, just taking the parameters, passing them through. And then, as we get further down the rabbit hole, we can handle any errors that happen here. So channel balance endpoint exists. We're calling get channel balance. We don't need to pass any data. So cool. Let's look at that over here now. New request. And channel balance. That looks right. Let's actually name these. Channel balance. This is invoice. This will be get balance, I think. Okay. Let's call it. Let's see what we get. Get channel balance is not defined. I bet you I forgot to import it. I did. Get channel balance. Boom. Okay, great. So that's nice here. It looks like it just gives us pretty simply our balance here at the top. Local balance, sats and millisats. I wonder how this would work with multiple channels. Remote balance. Oh, I see. Okay, so it's showing us here with local balance. It's showing how many sats are on your side of the channel. is 420. Versus for Bob, how many remote balance, how many sats are on his side of the channel. And he's got, 246,000 left, which that math doesn't fully add up. I'm guessing there's some fees involved there on his side. But cool, so that's nice. We can get both those balances there. And if you imagine like the pleb wallet we built, like if we want to show the balance for our pleb wallet, it's kind of an interesting problem here. Like, do we only show the wallet balance that's not open in any channels? Do we sum up the balance from the wallet and the channel balance? I don't know. These are good questions, but that will come further down the line once we actually connect into the front end and start to think about that. Or maybe you show both. Maybe you show like, here's the wallet balance that's not in channels, and then below maybe like, here's your channel balance. But just nice to start getting this information and just a simple API here. So let's continue though with this invoice stuff. We can now create an invoice, but how would we pay an invoice? How would we pay an invoice? I believe I looked this up before. I think it was send payment V2. That's it. Save us some time just parsing through all of these. Send payment V2 attempts to route a payment described by the past payment request to the final destination. The call returns a stream of payment updates. That's interesting. A stream of payment updates. Okay. So once again, we have a giant request object here with a lot of fields. And okay, they mentioned up here the call returns a stream of payment updates. So that's where we're saying let call equal this, and we're not just returning it or console logging it. We're able to say call.on data, call.on status. And so these are basically streams that we can subscribe to, I guess, to look at updates on these payments. So that's nice to know. This will be good for like once we start to get, like we're kind of testing this, building it right now, but once we would get it all working, we would want to be sure that like when we're writing data to our database, our transactions data, we'd want to make sure that something's paid before we write it to the database, for example. Or if an invoice was already in the database and it's unpaid, we'd want to update that invoice. So that'll be a little bit complicated if we get to that. I'm not sure we'll get that far. Got about 45 minutes left here. But let's see if we can get this payment through. So it's a huge request. There's a lot of fields here. I believe the question mark here, use base64 encoding. Okay, that's not what that means. I thought maybe that would mean it's optional. We shouldn't need to set the destination. We will set amount. We will set payment request. Bare bones invoice for payment within the Lightning Network. So amount, payment request. Gosh, I wish they showed better which of these fields were optional. It's nice that they have descriptions though. I mean, this is very good documentation nonetheless. We've got fee limits, we got a timeout. Allow self-payment, that's interesting. Didn't know you could do that. Okay, let's just try and send a payment request and an amount. Actually, no, we shouldn't need, the payment request will have the amount in it. So let's just try and see if we can just call this with our raw invoice and see if we can pay it. So router.post, and this will be, I'm just gonna call this like /pay. And oh yeah, we need to make the L&D method for it first. So we have create invoice. Let's do const pay invoice. So taking a payment request. I'm just going to call this invoice. Yeah, that's fine. And what is send payment on? Send payment is on the router service. Okay. So this is a little bit different. So we'll kind of do, just copy this, dot router dot send payment v2. Okay. Payment request is equal to invoice. Is that right? Payment request. Yes. So it's equal to invoice. We'll try to make this our only argument. Hopefully it'll work. I think it should. Then we'll return the invoice. Okay. Identifier invoice has already been declared. Okay. So we'll just call this paid invoice. Okay, and we'll export this function, and we'll actually remember to import it this time. What is it? Pay invoice. Okay, now here, const invoice equals request.body. So we're destructuring out from our request here, and then we should call pay invoice dot then. We take that success, we return it. Or else we return an error. Let's close this out. Something I'm seeing that's wrong right away is this is called payment request. Payment request is invoice. Wait, no, this is it's payment request here. It's called invoice here. Okay. This is where it's bad. It's just bad to use two different names. That is just bad. I'm going to call this payment request, just like that. So we're calling it the same thing across our files. We don't get mixed up with names here. So we'll pass in payment request, and we'll, yeah, just destructure that here at the top. Okay, cool. We import it. We imported it. Okay. So now make a new request, and I'll call this pay invoice. Just copy from here. This will be a post, and what is this? Just slash pay, slash lightning, slash pay, I believe so. We'll make our body, and we will have payment. Oh wait, I need to wrap this in quotes. Payment request, and it'll be equal to some invoice. So now we had Bob paid Alice, but now let's have Alice pay Bob. Now we only have this channel that's outgoing from Bob, incoming for Alice, so we need to have an outgoing channel to Bob now from Alice. So I'm going to open a channel from Alice outgoing to Bob. And we'll do 250,000 sats as well. And this should take a second. Nice. Right. So, and they both have funds. They both have the same amount of sats here still. So I want Bob to make an invoice now. So since we're only like our server's only connected to Alice's node, anything we want to do with Bob here, we're going to do it in Polar, and then hopefully more and more we can kind of like handle stuff programmatically on Alice's side. So I'm going to have Bob create an invoice, and let's just do 100 sats invoice. Node Bob, yeah. Okay, created the invoice there. Now I'll pass it to our endpoint. Let's see if Alice can pay. Let's see, is it gonna work? No. Okay, what did we get here? Timeout, unhandled error event. Timeout seconds must be specified. Timeout seconds. Is that something on our L&D here? Oh, yes, it is right here. Timeout seconds, an upper limit on the amount of time we should spend when attempting to fulfill the payment. So, okay, that makes sense. So this would be, I'm not sure if like, it's interesting that's timeout in seconds, because I wonder, like, if I set it to 10 seconds, will it retry? Like if a payment fails, like if it tries one certain route through the network and it fails, but it fails in 2 seconds, will it try again? I'm not actually sure about that. But that's where it's cool that now that we're working a little bit lower level on the L&D gRPC, like this is just all this stuff is just an invitation to kind of learn all these details about how Lightning works and actually get to work with it. Instead of using the abstracted LN bits all the time, we can get a little more lower level here and run into these questions and ask these questions. But if anyone in the chat knows, let me know. Like, is there like, maybe there's something for retrying payments. Route hints. Is there a max number of retries, or we can set a destination? It seems optional. But yeah, interesting question. Either way, it seems like we need the timeout. So we'll go back to our L&D method here. For pay invoice, we're saying payment request. Let's also add, what was it, timeout seconds? I like look at this and then forget it instantly. Okay, timeout seconds. 60, wow, that would be a lot. Let's just do 10. 10 seconds, okay, and let's try this again. This invoice should still be live and working. Failed, no. Okay, what do we got here? Is this the same error? Timeout seconds must be specified. It is specified. Send. Invoice is already paid. Oh. What the heck? Let's call our channel balance. Let's see, we should see this reflected. Oh no, it's failing now. Didn't connect server. It's because our server crashed. Oof, that's not good. This made our server crash. Let's just restart. If that was in fact paid, we should see it here. Okay, channel balance. So, yeah, now we have more of a local balance than just our 420 sats before. So this is from our channel that we opened, and this is the amount of sats sitting on our side. This is the amount of sats sitting on Bob's side. So we do see that reflected here, it seems like. Let's try and pay another invoice, though. I'm not satisfied with that. Bob, create another invoice. Let's make this one 200. Copy it, and let's try and send this again. So pay invoice. Paste that in. No. Paid invoice equals await, services router. What is happening here? Let's console log this. Paid invoice, let's see what we get. Do we even make it through this part? And what's happening on the router? The router is calling it, and then looks like we're probably just catching this error. Calling it, passing in payment request. Okay. Yeah, let's just console log this. Simple plevdev method. Is it going to tell us it's paid again now? Invoice is already paid. It is. And we see, it looks like this is the paid invoice that we're getting back. How do we keep accidentally paying the invoice but not getting a correct response? So annoying. Okay. Let's actually, I need to use the bathroom really quick, so let's take a quick 2-minute break. I'll keep this up and then we'll solve this right in a second. So, yes, okay. I will be right back. Okay, let's go. Let's fix this. Let's do it. Something is going wrong here. So I'm gonna look over. Look over at some of my old example code that I did here. Send payment sync. Did I do? We're using send payment v2. It looks like I used a different method here before. Is that correct? Send payment sync is what I used before. Oops. So what is this going to do? Send payment sync. Send payment sync is the synchronous, non-streaming version of send payment. Okay. So we had yes, because before we had this was asynchronous where we could kind of listen for these events. These events would be streamed to us. So we would have had to set up our endpoint differently for that. But here with send payment sync, it looks like there's no stream that happens. They just simply call the method and then they're console logging the response. So, okay, let's try send payment sync. Is this on router still? This is on Lightning service. How confusing, we're bouncing between services here. So Lightning send payment sync should be camel cased. Does this take the same arguments though? Payment request. I don't see a timeout here. Don't see a timeout. Cosmic Psyop, about my question earlier with like these retrying payments. Not sure, but time lock is a payment contract deadline. Yeah, that is true. Since we're using an HTLC here, we have a time lock field. Like that's at the lowest level in the Bitcoin transaction. So there is an expiry. I think that's where they call it expiry. That's probably not on this field, but yeah, there is an expiration. Every invoice can only like exist for 2 weeks or something like that. But I'm just wondering about like retrying payments. Like if L&D handles that for us in the background, that would be really interesting. And we just set a time, but probably for a future episode, given where we're at. But okay, so send payment sync. It looks like we have the same fields without the timeout in seconds. So let's just try it with this one field. Send payment sync. Bob. Sorry, we're wasting your time, Bob. We need you to make another invoice. 500 this time. And we will pass it to our server. Yes, okay. Beautiful. So we got a payment error field that's empty. That's nice. And it's showing us the route. It's showing us payment route. We've got hops, channel ID, channel capacity. So wow, we got all this information coming back to us. That's beautiful. But it looks like it was paid. So if I look, the channel balance should be, this is Alice going to Bob, or Bob going to Alice. Destination balance 0, destination balance 420. I can't tell. I think we paid this though. Is there an amount to forward 500? Okay, nice. So here's something simple we can do. Let's start thinking ahead now as we're making progress. So I'm also console logging this here, paid invoice. So let's say if we have an error, so paid invoice dot payment error, is this what the field is? Payment error, okay. So we can say if this is here, then we have an error. Let's actually do this. Let's do this in the endpoint. We want to handle this in the endpoint. I'm in the pay invoice function. Let's go to Lightning Router, pay. So if paid invoice.payment error, we will send a 500 and we will send the error back. So if there's a payment error. Otherwise, we will just return it. But if we have a paid invoice, this would be a condition where we would want to save this in our database. So I would say save tx to database. Nice. So this would be one place where we would save transactions to our database whenever we pay them. And yeah, and this is actually an interesting question for like the database side of things. Like we might create a lot of invoices, but do we want to store all of those invoices? I mean, I know that L&D at its lowest level does store all the invoices, so you can like make an RPC call. Like I think there's list invoices, exactly. So you can see all of your invoices. So we don't necessarily need to save the invoices in our database, but it would be nice to have a really simple transactions table that we can serve back to the front end where we can show every invoice that's been paid by us and then every payment we've received. So this is where we would save this to the database. And then on the create invoice, this is where things get a little bit complicated because we can create an invoice here, but then that invoice is just, it's kind of sitting open. How do we know when it's paid? And this is where we got to figure out. We need some kind of a stream for the invoice. I wonder, let's see, look over my reference code to see if I did this. Okay, it looks like there is a subscribe invoices RPC call we can access. Keep opening this. Subscribe invoices returns a unidirectional stream for notifying the client of newly added / settled invoices. That sounds perfect. The caller can optionally specify the add index and or settle index. If the add index is specified, well, what even is that? What is the add index in that? So add index, specified non-zero. Then we'll First, start by sending out notifications for all added indexes with an add index greater than this value. This allows callers to catch up on any events they missed. Settled indexes. I think what these indexes are is like add index, I think, is created. One of them is like invoices you're creating and invoices you're paying. And I think all of the invoices are like have an index, like have an ID number. And so you can start at a certain number. I wonder if we can just start at 0 for this. Because we want to just get all the invoices and we want to listen to any update that happens on an invoice. So if something gets paid, we can save that. So let's see. Let's just go ahead and start to build this function. So const, we're going to say, let's call this invoice stream. Invoice event stream. We call it that. So really specific what we're doing. And here, Copilot is guessing. This looks right, actually. Subscribe invoices. This lives on the Lightning service. Cool. Let's do that. We're not going to save this to a variable, though, because this is where we're going to do the call.on, like they're doing here, call.onData. So this will be a response was received from the server. Like any data change should be logged here. So this is what we want to kind of have a setup like. So subscribe invoices, we want to pass in our arguments, add index 0, settle index 0. Cool. Knew exactly what I wanted to do. Okay, and we're not going to put a semicolon here so that we can call .onData. It knows exactly what I want to do. Cool. And yeah, let's just console log that data for now. We have an on error, it looks like. That's cool, we can keep that. And yeah, that's it. So invoice stream. So what's interesting about this invoice event stream is that we don't necessarily want to put this behind an endpoint. Because I want this to kind of just be running. I want to have these events always streaming to where if a invoice gets paid at some random time, I don't want to have to call an endpoint to do that. I just want my server to be listening to it, and if it gets paid, it'll save it to the database. That's exactly what I want to happen. So I need to call this maybe inside of connect. Where are we calling connect? We call connect inside of server here. So as soon as we connect, let's also invoke the invoice event stream. So voice event stream, I think we can just invoke it like that, and that will start up this process. Basically start up a brand new process just listening for these events. Okay. And so now let's make this console log a little more obvious. So let's call it on data. We want to see what data. So now to see that this is working, I want to first create a new invoice, and I'm going to have Bob pay it. And when Bob pays it, this will not be calling any API endpoint. When Bob pays it, though, I want to see this console log fire. That would show us that this is working, and that means we could save it to the database and just, yeah, kind of see what fields are there. So let's create a new invoice now. Create invoice. Let's make this 660. So this is for Alice. So we have a new payment request. Let's see if we console logged anything. Okay, so we already console logged on data. So that's this console log. And it's telling us that there's an invoice. It has our memo here, has the value. But we see that settled is false. It's telling us it's not settled. And the state is open. So that's good. So it looks like we get these events even when we create invoices as well. So let's see if we can get this settled to change to true once we pay this invoice. So Alice created the invoice. Let's have Bob pay this now. Actions, pay invoice. Successful. And okay, new event here, settled true. Awesome. And then state is settled. Okay, beautiful. So our stream is working. So it seems like this is just passively listening now. Like, I mean, if I go and I create another invoice, it's listening for that one. We have a new invoice, open, settled, false. So very cool. So that's our stream is working. I want to look at this settled one though. So I guess what we can now say is right here in our event listener, I can say if data.settled, yeah, I've got a console log invoice settled. That's fine, but let's actually just put a comment here. Yeah, save transaction to database. So now like this inside of here, this is like the final point when we know an invoice that we created was paid. Just like on our Lightning router, right here on pay invoice, when we get back the response and we show that it's not an error, we know that we did pay this invoice, so we can save it to the database. Nice. There's probably lots of edge cases that I'm maybe missing here for other error scenarios that can happen, but this is our very naive kind of standards that the payment needs to have before we decide to save it in the database and call it paid or not paid. But that is very cool. So now we have the payment stream. So now we're creating invoices, we're paying invoices, we're getting our balances here. I mean, gosh, what comes next? I guess I've got about 20 minutes left here. And so that was a lot of what I wanted to show on at least the API and the server side. So now is the question of, do we maybe want to connect our Pleb wallet to this or something like that? Or do we want to start with the database stuff? The database stuff will probably take too long. So let's do this. Let's connect this to our Pleb wallet locally in our last 15 minutes here. So I've got Pleb wallet React here. I probably have this on my machine, but I'm gonna clone it again. And we'll just go to CD desktop. Okay. I'll open this now. We'll need to install and hopefully just rewrite these endpoints in a very basic way. So npm I will install packages here. And yes, let's start to look around. So it looks like this is the version where I used our environment variables. So have to keep that in mind. Get wallet balance. Process env. Get transactions. Update chart data. Let me actually see if I have an older version on my computer here that has the environment variables, because I don't want to go like add those in. That would be a huge waste of time. Of course, where's one? Pleb React. Maybe this. We should see a .env. Cool. Okay. Doxed. There's my key. I dox an environment variable every stream, so this is just like, this is becoming a trend. But cool, we have our environment variable in here, so now we need to install this, but it should just like run and work. And then we can change some of these API calls. So npm I, once again. That was fast. And then npm Okay, our front end is loading. Let's see if something's gonna break. Starting up. Okay, cool. Wow, it still works. So we're getting our balance here from our old LNbits wallet from Course One. We're getting the price. That's just coming from Coinbase though. So let's start first by updating this balance. I'm gonna update this balance API call. This is in app.js. So get wallet balance. So we will not need headers for this. I don't think so. And we're going to call our local endpoint for our balance. We're just going to get wallet balance for now and not really combine the balances yet. So I'll copy this. Lightning/balance. And then right here we're dividing by 1,000, but this balance will actually return. It won't return it in millisats, I don't think. Yeah, it'll just be sats, so we don't need to divide this by 1,000. Gosh, what does that field called? Total balance, total_balance. res.data._balance. Okay. Let's see if that works. Whoa, yes. Here we are, okay. So now we've got our front end is talking to our new API. We're getting our wallet balance. That's very cool. Where are we posting this balance right now? Balance equals balance. Let's just add on an H2 here. And we'll say this is channel balance. And yeah, let's just hard code it for right now. Okay, let's, do we want to call another endpoint for this? Screw it, let's do it. Const get channel balance. And we will do something very similar here. And we'll call it right here on render. When everything renders, we'll call it channel balance. And this one will be channel balance. And okay, what do we get for channel balance? We just get a balance, a local balance, remote balance. Let's just grab balance from here. That works. So this way, the user of Pleb Wallet, they're not just seeing their wallet balance with some of their sats missing because they're in a channel. They can at least see both. But we're not going to set balance. We're going to set channel balance, which doesn't exist. So add that here. Beautiful. Channel balance, we set it. And then down here, we'll say, yeah, channel balance sats. Reload again, and boom. Our channel balance is now there, so now we can, we could sum this up for the user or show them both, but we're just showing them both right now. Kind of broke our UI here, but whatever. Beautiful, so we're getting balance and channel balance. But transactions, we don't have a transactions database yet, so we can't get transactions, but we could get, let's actually do a create invoice. Let's update our create invoice function. Let's do that. Is that in here? Get transactions, channel balance, wallet balance, components. There's buttons and there's payment modal. Payments modal. Okay. Yeah, handle send, handle receive. Cool. So we're going to do handle receive because we're going to create an invoice. So I'll paste in our URL here. Our data, we don't need this outfield. That was something for Ellen Bits. We don't need this header. Setting invoice, and it is payment request still, so I think that's right. Actually, what does this return? If I create invoice, payment request, yeah, that's right. So we're grabbing the payment request field from response.data. We're setting that to invoice. We're passing an amount and memo. It's supposed to be amount, it's supposed to be value. It's good to know. So we'll call this value. Okay. So, and I think the UI should like handle the rest. Let's see. So receive, I'm gonna enter an amount, we'll do 420, our classic number. I should pull up the console before I submit this so we can see if something breaks. Submit, invoice created, okay. So we created an invoice from our front end. Let's decode this. Did we create it correctly? Let's decode it. Yep, chain reg test amount 420. And can we have Bob pay this? It's time to pay up Bob. Let's go. Invoice paid. Beautiful. So we created a real invoice, it worked. We see now here back in our server repo, we can see where, yeah, this memo Ellen Bits transaction settled is true. So that's pretty cool. We're now creating invoices. Man, oh gosh, we're at such an exciting point, but I'm coming to an end here. But yeah, let's, okay. That's very cool. So we now built a simple API that is starting to be able to replace the Pleb wallet, which has a non-existent backend. Like the Pleb wallet here was just using the hosted legends.ellenbits instance, their hosted node solution. So now we're kind of running development here on RegTest. And let's talk about how this would work if we were moving forward. Let's spend the last little bit of time doing that. And I can also, like, if you've got any questions or comments, you can throw that in the chat. But yes, so I guess the final version of the final version of this project that we would get to, we have like the Pleb wallet is hosted on Vercel right now, but we're making this separate code base. We're making this different code base, Pleb wallet backend. So we would actually deploy it somewhere else. Which you can do that a lot of places. There's like Azure and AWS. I like to use Heroku, but you know, we could probably in the course of like 15 or 20 minutes deploy this to Heroku, and Heroku would give us a production URL. A production URL, it wouldn't be localhost, and we would basically go in and we'd replace like where did we add that? Yeah, we would replace this local host 5501. We'd replace that. It would be like Heroku Pleb wallet backend /lightning/invoice. And so that'd be nice there. And there's kind of the two different environments. It can be really confusing because we have right now we're local on both. We're local on our backend. We're local with RegTest and Polar, and we're local with our front end. But then the final version, we would have our front end in Vercel. It would be talking to our hosted backend, and then our hosted backend, where we grabbed these variables, the host, the cert, and the macaroon, we could actually grab these from Voltage. So we could have our hosted Voltage node and our hosted database, or server, that is. And so that would kind of be the final setup. I think for the second Pleb Dev course, that's going to be like the first project. But there's this whole aspect of the database missing from this little example project we did. I felt like like 2 weeks ago when we did the last live hack with the Next.js and Mongo. I felt like I should have started with like the hardest thing first, and we ended up getting stuck at the end. So that's why, like for here, I wanted to start with like, okay, let's get all the methods where we're talking to L&D. Let's get that up and running. Let's get them behind endpoints first and like thoroughly test it, and then figure out where we will drop data, at what point we will save data to the database. And then from there, like we would have examples, we'd have all these example invoices that we console logged. From there, we can kind of create like a really simple transactions database table, and then set it up locally and deploy it, and yeah, like start to have the full shebang going, the full stack Lightning app that we all dream of building. But yes, that is exciting. I'm surprised we didn't really run into any problems there. It's kind of like a few little syntax errors, some stuff like that. I'm glad you can follow. Yeah, I'm trying to like, I have a problem with rushing through things, talking fast sometimes. So I was like, okay, let's really just like, let's get low level here with the RPC, and let's just really think about all the things we're doing and talk through it and go through it slowly. So a bit of a trade-off there. We don't make it as far into the project, but it's a great place to get set up. And this will be a great kind of a simple, I guess, boilerplate for like a Lightning server that you can all take. In fact, I'll go ahead. Let's push this to GitHub right now. I can stop my server here, get status. Oh, and we need to be sure, as always, to not commit .env. That's why you run git status. Check ourselves. Okay, that's gone. Git add, we'll get commit -m. We'll say initial pleb wallet backend. Spelled that wrong. Boom. So we can commit that, and then I'll just go ahead and go to my GitHub here, and we'll make a new repo. Call it pleb wallet backend. Select me as the owner, public. I'll leave all of this blank. And then GitHub will generate this command that I can copy to push an existing repository. Because if you remember at the beginning, we did git init to kind of initialize so we can get remote at origin. Okay, and then git push. It makes us set the upstream. Okay, boom. So this is now public for anyone to copy, rework it, tear it apart, critique it, tear me apart, do what you do. Yeah, it's definitely a lot of info. And this is where, like, for me, these live streams and these workshops, they're gonna be like a little more rough and tumble. Like I'm gonna try and explain stuff along the way. But then eventually, like, since this is me basically building the second course live in person. Like, this is a prototype project that will become something in the second course. And so since I've done this first live stream, now I can go take this project, I can finish it, and I can go take this information and I can bundle it up and kind of make it like a really tight presentation, break it up into segments and make it easy to follow. So that's kind of my goal for the live stream. It's almost just like a way to like show up here and make something for the week, make a piece of content, but still be able to like be continuing my research and my work for the second Pleb Devs course. Cause that's kind of like, yeah, that's my big project right now. I'm just sprinting as hard as I can to get these projects finalized and then kind of break them out into slideshows and live examples. And so, yeah, that was the whole purpose of this, but a pretty good, got pretty good results here. And yeah, I guess, wonder if there's anything else I wanted to touch on. Um, yeah, I don't think so. I mean, I'll say this, like, if you have specific questions, or if you're trying to like copy this, you run into problems, hit me up on the Discord, the Pleb Devs Discord. I'm on there all the time, so super available for any questions. And yeah, once again, if this was a little bit too advanced for you all, I know for many of you this might have been your first exposure to Node.js, and we kind of hardly touched on it and just got into Lightning stuff. But yeah, if you have questions about that, like happy to help as well. But cool. I mean, thank you everyone for showing up. Hope it was worth your time. And yeah, I'll be posting a recording for this on the YouTube soon. And we're just going to keep building. I have no idea what the workshop's going to be next week. We'll come up with something, give me suggestions. And yeah, just any feedback or suggestions you have. Would love to hear it, because just trying to I don't want to be the face of Pleb Devs. I want to just help spawn this community where we can all start to help each other, because I know a decent amount, but there's still a lot that I'm not good at that all the other Pleb Devs can help me with. This is a wallet demo on YouTube. The wallet demo, we built the Pleb wallet in the Pleb Dev course #1, and so you can find that at udemy.com if you search Pleb Dev course. Or if you want to, and it's like $15, I think. Also, if you want to pay in sats, it's on an app called Emeralize. That's spelled like Emeralize. How do I do this? Yeah, like that right there. So that's the best way to get it. I want to release the first course for free once we finish the second course. I'm not the only one that was a part of producing it, so it's not fully my call, but I do want to release it for free so you don't even have to pay the $15. But also there's another place you can go. If we go to organizations here, I have a Pleb Devs and repo. Okay, let me copy this, and where am I going to post this? I'll post this in the Discord right here for everyone to see. So if you join the Discord, you can grab this link, and this is the slides and the GitHub repos for each of the projects we do. So this is essentially the Pleb Dev course 1 without the videos. So this is another option if you don't want to pay for it right now. I don't want to charge much. I didn't want to charge any money at all. In fact, I want to make it as accessible as possible. So if for any reason you can't afford it, you need the full thing, let me know. We'll set you up. But yeah, so here's kind of the full repo that contains all the links to everything else. But yeah, the Pleb wallet, the Pleb wallet was it was a front end only. It was just a React app. And it's not super secure. You're not using your own node. There's definitely trade-offs to it. But for the first Pleb Dev course, my goal was, what is the most we can do with Lightning without having to get into backend? Because I thought that if I had to show you zero to coding and front end and back end in one course, it would be too much. So we just made this trade-off, okay, let's do it only front end. We'll get him set up with the basics, HTML, CSS, JavaScript, and then we'll start to interact with LNbits so that we can make a little wallet, just a web page that's a working Lightning wallet. And so that's what the first course covers. And then the second course here, I'm going to try and get the other side of that, get the backend side where, okay, let's make our own API, let's make our own database, let's deploy it, and let's get to that full stack Lightning app that has been traditionally so difficult to get to. I started learning how to code because I loved Bitcoin, and it's been 3 years of maybe 2.5 years of me trying to mess around with Lightning and my basic pleb apps, and I haven't really been able to make progress like this. This is some of the furthest I've gotten. I'm really at the edge of my knowledge, and as far as I've gotten as a Pleb Dev working with Lightning. And so it's really exciting. Now is a time where it's easier than ever to kind of use all of these tools together, stuff like Polar, stuff like Voltage, this LMD gRPC library we're using. We've got all of these tools now that we can do to kind of abstract these difficult concepts and make it easier to make your simple full stack Lightning app. And this is the future I'm bullish about. Just like my goal is if I could do like a live workshop or a live presentation where I build a Lightning app from zero in like 30 minutes. Like that's my dream, is to be able to show someone just like how you can create a simple React app. Like I want us to be able to make Lightning app templates like that eventually, and just lower the barrier to being able to build apps on Lightning, because I mean we need more app builders on Bitcoin and Lightning, and it's hard. And like on the protocol, at the protocol level, like with the protocol engineers, they have to be really careful. They got to think through all these trade-offs. They kind of move slow and fix things. But on the application layer, if you're building apps on Bitcoin, apps on Lightning, that's where you can move fast and break things. That's where it's good to experiment. It's good. We want to iterate as fast as possible. And the app development side of being a Bitcoin dev is so under recognized. It's so like there's so little resources on it. Like that's kind of area that I'm focused on. I want to build out. And I think, that's what the pleb devs want too. That's what some people want to be, a protocol dev, and that's awesome. Who knows? Maybe I'll be a protocol dev one day, but for now, I'm just stoked to be building apps and to be kind of pushing to those next steps on that journey. But yeah, cool. That is enough of my ranting. I could do it all day, but this was a fun 2-hour live hack we did here. We'll probably pick up this project again in 2 weeks, or maybe the last project we did in 2 weeks, something like that. But we'll keep pushing forward, and eventually, this stuff, it'll be bundled up into the second course, and it'll be a little bit easier, quicker to digest. So with that said, thank you again for joining. Another live hack. The building never stops. And just hit me up if you're new. Hit me up if you're stuck. Whatever you got going on. I'm excited to connect with any of y'all. But thanks for tuning in, and I will see you all next week. Do a good salute there. Boom.